here we go. So there's going to be three main properties that we are going to work with today. All right, and utilize. So property one here. Okay, we have log base A, so this is a generic base, okay, of u times v. Okay, and I'll try and make my v look very pointy there so that way you don't get confused. All right, so log base A of the quantity u times v. All right, and then does anyone remember from their time in Algebra 2 what that equals? Ooh, okay, well, that's fine. So log base A of u plus log base A of v. Is this, like, do you remember this from Algebra 2 a little bit now? No? Okay. But yes, you said Ethan? Okay, who did you have? Thompson. Okay. Dan, you remember it too, you say? Okay. All right, so, what's that? We're going to change the base later. Yep, we'll do change the base later. Yep. Okay, so let's do a quick example of this. So, for example, let's try and simplify log base 4 of 16x. Okay, so you log base 4 of the quantity 16x. Okay, so, well, do we have a product here? We do, right? We have 16 times x. So we could rewrite this as log base 4 of what? 16 plus log base 4 of x. Okay, so there we utilize the property. Okay. Oh, are we done? No, because what can we still simplify here? Yeah, what is log base 4 of 16? It's 2, okay? And so you can see the use of kind of breaking up a single logarithm because sometimes you can simplify it, okay? Sometimes you can simplify it like this, all right? Because it might not, you might be like, again, by the definition or our understanding of the word simplify, right? Taking a single logarithm, breaking it up into 2, that's like, well, that looks more complex now. We've made it 2 things instead of 1 thing. But the purpose was so that we could simplify one of those, okay? So that's the idea. All right, next property. And Dory, we'll get more practice with these properties. I just want to give you a quick little intro to each one first, and then we'll get some more serious ones. All right, log base A of u divided by v. All right, well, even if you didn't know these properties before, you can probably guess what this one's going to be. It'll be equal to log base A of u minus, yes, very good, log base A of v. Okay, that's a nice part about math, is there's kind of like, you know, balance to things or whatever, or corresponding properties. So yes, if you have multiplication inside of a logarithm, that becomes addition outside. If you have division inside a logarithm, that becomes subtraction outside between two logarithms. Okay, so a quick example of that. Natural log of x over 2. Natural log of x over 2. Okay. So this would break up into what? Natural log of x minus natural log 2. Like that. Yeah. So there's the idea. Now, we can do some other stuff here too, right? I mean, so for example, this natural log of x over 2, maybe you don't want to think of that as x divided by 2. We could also think of that as natural log of 1/2 x. Is it not the same thing? Right? X divided by 2 is the same thing as 1/2 times x. Then we could use the other property. Yes, natural log. Ln. So you can look here, it's like, well, wait a minute. We start with the same thing. Here we end up with natural log of x minus natural log 2. And here we end up with natural log 1/2 plus the natural log of x. But if we started with the same thing, these two things should still be equal, right? But 1/2 is really 2 to the what power? Negative 1. And so we could say this, okay? And there's one more property we need to learn here before I can show you that they are in fact the same. And that's the next one. So we'll come back to that one. So hold that thought. The next property we have is that log base A of u to the n is equal to n times log base A of u. Okay. So in other words, right, when you take the log of something to a power, you can bring that power kind of out front and multiply in front of the logarithm there. Okay. So then back up to here where I was kind of like showing you an alternative way to do this, to evaluate this logarithm. What can I do with this -1 right here? Yeah, bring it down in front. And so we end up with negative natural log of 2 plus the natural log of x. Is this the same as this? It is, right? I could flip around the order and it'll be natural log x minus natural log of 2, which is exactly what we have right there. Okay. So again, multiple paths to take here. Most likely you would do this one, but just to show you that you can kind of like fool around with these a little bit and do it in different ways. Okay. All right, so let's do another one, a little example of this one, a little exemplar. How about log base 3 of 9 to the 5th? Okay, log base 3 of 9 to the 5th. Okay. By the way, it doesn't matter what the base of the logarithm is. Whatever your base is, if you have something inside your logarithm that's raised to a power, that power can come out front. So in other words, here, instead of log base 3 of 9 to the 5th, I could write 5 times, right? Log base 3 of 9. No, you don't have to. I just do it just to make it, I don't know, make it more obvious that that's there. But yeah, if you just put the 5 in front, that's understood. Okay. What is log base 3 of 9, though? 2. So this is really 10. It's really 10. Because this is equal to 2. Okay. Now, that is the end of our rules. So in other words, log base A of u plus or minus v has no rule. Okay? And I'm going to put this as a star here, okay? Because this is confusing to some students, okay? If you have addition or subtraction inside the logarithm, there is no property to break up that. You have to leave it, okay? You have to leave it. Almost like, maybe in a similar sense to like how we have square roots, right? The square root of a sum or the square root of a difference, you can't break the square root up over that sum or difference, right? But you can break a square root up over multiplication or division, right? You can break it up, but not for addition or subtraction. Same thing holds true for logarithms. The logarithm of a sum, logarithm of a difference, those cannot break up. Okay, so you have to leave them the way they are. All right. That's not saying that there's not ways to simplify other parts of it, but the sum of the difference, you cannot break it up. Okay, so don't try and do that. All right, but inevitably, that is a temptation, at least for you guys. I know, because I see it happen. All right, so how are we going to use this? Well, so let's, for example, evaluate the following. Okay. So number 1, this will be an example here. I'll have you guys try one. Let's do another one. We'll say log base 5 of the square root of 50. Okay. So our goal here, by the way, in evaluating is to just basically simplify it as much as possible, right? Our goal is to not use a calculator, because we could, but we're not. Okay, we're going to just simplify it as much as we possibly can. So what might be a good first step here to help us kind of simplify things? Yeah, Jenna?
Change it into exponent form?
Aha, so we could, you're saying like rewrite this in exponential form? That could be something we would do here. But let's use our logarithm properties to simplify. Yeah, let's do that. I'm not sure. I'm trying to think about. That would give us something. I don't know. Yeah, but that would give us something for sure. So let's for example take care of this square root. All right. I see what you're trying to do there, but I want to keep it with log properties and stuff. So the square root, okay, that's the same thing as to what exponent? 1/2, right? Okay, and now that we have that exponent there, what can we do with this exponent? Bring it out front, right? So we'll have 1/2 log 5 of 50. And is that the best we can do? Well, since we're base 5 here, maybe we can try and break up that 50 so we have some like powers of 5. Okay, so for example, we could say that 50 is really like 25 times 2. Okay, and of course the 2 I don't really care too much about, but why is the 25 good? It's a power of 5, right? We'll be able to simplify that because our base is 5. So yeah, we're going to simplify this. All right, so we have multiplication inside of our logarithm, so we can change that into what? Addition, right. Now, the 1/2 that's in front of this logarithm, okay, it will distribute to both terms. Okay, so when we change this multiplication into addition, the 1/2 is going to go both with the log base 5 of 25 and with the log base 5 of 2. Okay, it distributes like both logarithms there when you break it up because it was already in front to begin with. Okay, like so. Okay. What is the log base 5 of 25? It's 2. And then log base 5 of 2, can we evaluate that? No. No, unfortunately not. Not easily, right? So, 1/2 times 2, though, we can say is 1. So we have 1 plus 1/2 log base 5 of 2. Okay, can we simplify that any further? No. So that's as far as we can get. Okay, if we want to check ourselves, okay, if we want to check ourselves, well, if you have the calculator that has the log base on it, then it's pretty easy to check yourself. If you don't have a calculator with the log base, we don't really know how to do a log base 5 if you don't have the log base command. All right, but I'll show you what we're going to do later. So, but I can do it. So log base 5 of the square root of 50 is that decimal. And then we'll take the 1 plus 0.5 log base 5 of 2, and they're the same. All right, so we did do it right. We simplified it. They're still equivalent. Okay, so here's one for you to try. Okay, we'll say the natural log of 4e to the 5th. Natural log, excuse me, 4e to the 5th. The base is, so it's natural log, so that means the base is e. That's basically, I mean, the only other thing you could do, but again, I would say it's debatable, but simpler is you could rewrite that as 2 squared and then write the 2 in front of the exponent. But I would debate whether that's even, simpler or not. So what you have there is yep, so far so good. And yeah, answer looks good. So, here you want to be careful. What is being raised to the 5th power here? 4 and the e? It's just the e. Yeah. If it was 4 and the e, you'd have parentheses around. You'd have like a further set of parentheses around the 4 and the e together. So it's just e. So you can just get rid of those 5s in front of the natural. So, what's being raised to the 5th power here? So it's not the 4e, it's just the e. Yes. If it was the 4e, you'd have a further set of parentheses around the 4 and the e. So it's just e is being raised to the 5th power there. Just the e is being raised to the 5th power there. So you don't want to bring that 5 out just yet. You want to break it up and then bring the 5 out. Sorry, what was that, Grant? what power gives you e to the 5th? Yeah, so there it is. Okay, so so one thing I want to mention here, and I get it because we kind of did this right over here, right? So in this situation, right, the 50 was the only term inside, and so it was the entire term essentially that was inside there was being raised to the 1/2 power. Whereas over here, the entire term is not being raised to the 5th. Only the e is being raised to the 5th. So our first step here, we don't want to bring that 5 out first because only the e is being raised to the 5th power here, not the 4 as well. If it was the 4 and the e being raised to the 5th, you'd have like an additional set of parentheses in there. So instead, we want to break it up first, natural log of 4 plus the natural log of e to the 5th, okay? And so natural log of 4, that doesn't really simplify any further. But natural log of e to the 5th, we can simplify that. What does that equal? 5, right? Okay, and so we end up with natural log 4 plus 5. And that's as far as we can go. You could, if you really wanted to, rewrite 4 as 2 squared. And then using our properties, bring the 2 out front. Is that simpler or not? Debatable. All right, but that is like a further simplification you could do there. Okay, that is a further simplification you could do. All right, so question, Jenna?
So where does the, like, in the second step, where does the ln of e go? Why does it just go to 5?
Because what is natural log's base?
Log
E. And so then e to what power gives e to the 5th? 5 does. Okay? Questions on any of that? All right. Yes, the fun is just beginning. Don't worry. All right. So the next thing we can do with this, besides evaluating, we can also expand. Expand. Okay. Oh, yes. This is exactly what I wanted to do on a Friday. All right, here we go. So let's do log of 5x to the 3rd y. Okay, so since we see just log without a base, this means log base 10. That's right, okay. Okay, and so we want to expand. So that means we want to rewrite this as a sum or difference of logarithms. Okay, right now we have a single logarithm, and we want to expand it wherever we can into a sum or difference of logarithms. Okay, so we have 5x cubed and y, and these things are all being, well, what operation is happening? Multiplying. So all those multiplications are going to become what? Addition. Yeah, that's all. So we have 3 terms being multiplied, so we're going to have 3 things added together here. So it'll be log of 5 plus log of x cubed plus log of y. Okay. Can we simplify log of 5 any further? No. Can we simplify log of x cubed any further? Yes. What can we do? Bring that 3 out front. Okay. And again, I would say it's kind of debatable whether that's simpler or not, but we'll go ahead and do it anyway. And then can we simplify log of y any further? No. So we're done. There's no more products to expand to addition or division to expand to subtraction. So that's the answer. Okay. Let's take a look at another one, because I know these can be a little tricky. These especially because you don't really know when you're done. The other ones that we're going to do later, the condensing ones, you kind of know when you're done because you get it to a single logarithm. Here, you're supposed to kind of like go until you can't anymore. And so that's kind of like on you to decide, well, can I go further or can't I go further? That's a little trickier. So I get that. 20 times the square root of x over y. Natural log of that. Okay, so what kind of operations do we see in here that we can expand? I see multiplication, we can expand that, and what else? Division as well. We're going to expand that one as well. Okay, so we should see an addition show up, right? We should see a subtraction show up. We also have that square root, right? And our square roots in this case are not super helpful, okay, as a symbol. So we should probably rewrite that square root as what? 1/2. Exactly right. So let's go ahead and do that first before we kind of get into our expanding. Okay. Now, with rewriting it like I did right there, can I go ahead and bring that 1/2 out front now? It's an exponent. Can I bring it out front? It's only applied to the x over the y. So we don't want to do it just yet. Okay? We don't want to do it just yet. All right? If it was the entire quantity, if it was 20 times x over y, all raised to the 1/2, then we could bring the 1/2 out front. But since only the x over y is being raised to the 1/2, we need to break this up first. So, what operation are we going to break up here? The multiplication. So break up the multiplication with the 20 and the x over y 1/2 to make it addition. So we'll make this natural log of 20 plus natural log of x over y to the 1/2. I should probably set like another set of parentheses there. Okay, so it's 20 times something. So it's natural log of 20 plus the natural log of that something. Okay. Can we go ahead and break up the division now? No. What should we do first? The 1/2 needs to come out, right? Because we can't get to the division right now because it's inside that to the 1/2 power thing. So we'll bring out the 1/2, and now it's just natural log of x over y. Okay, and then the division will become what? Subtraction, right? So we'll still have the natural log of 20. Don't forget that. That 1/2 will now distribute to the natural log of x minus 1/2 the natural log of y. Okay, and then that's our final answer. Okay, that's our final answer. Okay, yes, 20, you could break it up and say it's like 4 times 5, and then you could have natural log of 4 plus the natural log of 5 if you wanted to, but again, I would argue that's not really simple because it doesn't really simplify it any further. So, you know, I don't know. Yeah, you could break up the 20 if you wanted to, but I don't think that's important. All right. Questions on any of that? All right, you guys ready to try one then? All right, here's one for you to try. Let's see. I'll just change this up to log, I don't know, of the square root of 3x plus 5 over 7. Okay? So log of the square root of 3x plus 5 over 7. Give you this little hint. Do we have a property for breaking up addition inside a logarithm? We do not. Okay, so unfortunately not. We can't get to that 3x and break it up because we have a plus 5. Yeah, we're going to have to just leave it unfortunately. So, yeah, that's right. Yeah, that's it. Yeah, you got it. Is that it? Yeah, that's it. Yeah. So the 1/2, be careful, it comes in front of the logarithm. I see you brought it down, but make sure it goes out in front of the logarithm.
Wait, does it go in front of both?
Good job, gents. Okay. There it is. 1/2 log 3x plus 5 minus log 7. Okay, questions on any of that? All right, so that was expanding. Now we're going to condense. Okay, which the typical directions are like rewrite as a single logarithm. Okay, rewrite as a single log. We'll do 2 of these here. 2 log base 4 of x plus log base 4 of 5. Okay, so essentially this is the exact reverse of what we just did, right? Previously, we took a single logarithm and we expanded it out. Now we are taking that expanded logarithm and rewriting it as a single logarithm. So it's kind of like digging a ditch and then filling it back in now. Okay, and we can just keep going on and on and on. All right. So we want to combine this together as a single logarithm. All right, I see some addition between 2 logarithms here, and I also see a 2 in front as well of just the first term there. Okay, so what should we probably handle first here? The 2. Okay, yeah, we want to handle that 2 first because right now we can't really combine logarithms if they have coefficients in front of them. All right, so with the coefficient of 2, we need to bring that back up inside first. Okay, and now that we have a log plus a log, and they're both the same base, right? That's really important here too, right? If these were different bases, would we be able to combine these 2 together? No, right? It's got to be the same bases. And so, right, but since we have addition between 2 logarithms, we can rewrite that as what on the inside? Multiplication. So 5x squared or x squared times 5, however you like it there. Okay, and yes, that's as far as we need to go. All right, let's try another one here. 1/2 natural log 5 minus 3 natural log of x plus 3 plus the natural log of x. Okay, there's a couple ways we go about tackling this too. I'll try and do the most straightforward approach so it's not confusing. All right, so what should we take care of first here, do you think? Yeah, the coefficients, right? So we'll bring that 1/2 up and make it natural log of 5 to the 1/2. Ooh, do I like how that works? I don't like how that looks. Let me change this. Okay, and then minus. Okay. Sorry for my overzealous use of parentheses there, but I just want to make sure we understand where things are inside or outside of the logarithm and stuff like that. I guess I can put parentheses here too. Just group it all. All right, so we've taken care of our coefficients. I see subtraction and I see addition. So my suggestion to you when you come across like more than one thing like this is kind of work your way from left to right. Okay? Work your way from left to right. So let's just take the first 2 terms here. Okay, almost like order of operations, right? You'd subtract here first and then you work with the addition. So let's just take these first 2 terms here together. How can we combine these together? Using what operation? Division, yeah. So it's going to be natural log of the quantity 5 to the 1/2 all over x plus 3 to the 3rd. And we still have that plus the natural log of x on the outside. Okay. Now again, I'm taking this step by step. For those of you that, maybe you might be able to look at this and just be able to put it all together at once. Or after some practice, you'll be able to put it all together at once, right? I'm just going to take you very step by step just to make sure, because this can be confusing. So we want to make sure we have that like solid base layer before you start trying to like jump steps and stuff like that. Because you totally could just, you know, probably some of you might be able to get to the point where you can just do it right from here, okay, and just get the answer, which is great. All right, last but not least, we are adding between two logarithms, right? And so that means we're going to make that into multiplication. So when I multiply x times this fraction here, where will the x end up? In the numerator, right? Because when you multiply, right, this is really like x over 1 here. So when I do x over 1 times this, well, the numerators multiply and the denominators will multiply. So the x will multiply up to the numerator, and the denominator of 1 will multiply down to this denominator here. So yeah, we're going to end up with 5 to the 1/2 x all over x plus 3 to the 3rd. Yeah, that's fine. Yep. Absolutely. All right, and so there's our final answer. Okay, question?
Can the x go on the outside? Does it have to be
I see what you're saying. So you want to maybe like have it like that? Yeah, that's fine. Yep. As long as you recognize, though, that it will be the same as this. Because again, for example, our quiz won't be multiple choice, but like the test, you know, if you come up with this and then your multiple choice looks like this, just make sure you can match it up. That's all. But if you're good with that, then yeah, I'm cool with that too. You've answered the question, so there you go. All right. Any other questions on that? All right. Last question then. Or last topic. Okay. So what do we do for these people that don't have the nice fancy calculators that let you do log base anything, right? What if I want you to evaluate something like log base 4 of 30, right? We don't have a way to come up with the exact value or the exact power of 4 that gives us 30. Again, we have an idea, right? It's going to be between 2 and 3. Because 4 squared is 16 and 4 to the 3rd is 64. So 30 is between 16 and 64 there. So it's going to be between those two numbers. But we're not sure exactly how to evaluate this, right? And if we're trying to evaluate it on our calculators, and if we don't have that log base, the only logarithms we can do on our calculators are log, which is really log base 10, right? Or natural log, which is log base e. All right? Well, we're going to do something, okay, where we can take this logarithm and we're going to translate it into another base. Okay, so we're going to change the base into a base that we can calculate, right? So either we want to change this into log base 10 or we want to change it to log base e, right? Natural log or just the common log. So how do we do that? Well, it's actually very easy, okay? I mean, if you want to change it into log base 10, then you'll just write this. Whoops. Or if you want to change it into log base e, you'll just write it like this. So it's just literally whatever base you want, you do log that base of the big number divided by log that base of the base number that you're shooting for. Okay? So if we want a log base 10, I'll do log base 10 of 30 divided by log base 10 of 4. Or if I want to do natural log of 30 divided by natural log of 4, or any other of those, you know, any other base. Of course, these are the two that we're going to be using because that's what our calculator has. But either way you do it, you'll get the same answer, which is kind of interesting, I think. You know, we end up with log of 30. Make sure you close that parenthesis, though. Otherwise, you're going to get the wrong answer. All right? Or you can do natural log of 30. You see, you get the same exact value. Okay? So that's the change of base. That's change of base. Okay? That allows us to convert into a different base here. We can do it even with something, you know, like log base 2 of 32, right? We know what log base 2 of 32 is. Bless you. What is log base 2 of 32? 2 to the 4? 2 to the 4 is 8. No, wait. 2 to the 4 is 16, I mean. So it's 2 to the 5th. Yeah, 2 to the 5th. This is 5. Okay? That's 5. Okay? But we could also do log of 32 divided by log of 2, or we could do natural log of 32 over the natural log of 2. And if we do that, there it is, 5, or natural log. 5 as well. Okay. So there it is. Questions on anything? Okay, so that's all I've got for you today. Wow, I finished in time to give you guys enough to work on either your population project or your homework. Alrighty, so let me get that posted up here for you.